Hello everyone, I'm Ethan, and today we are going to uncover a mysterious topic that 99% of people have never ventured into or even imagined. That is, we may be living in a black hole. One day in 2023, astronomers from NASA captured a faint light through the Webb telescope in the distant cosmos, originating from an early galaxy. Surprisingly, this early galaxy, known as UHZ-1, formed in the early universe, and its mass was equivalent to 140 million times that of the Sun. This early galaxy, UHZ-1, was formed in the early stages of the universe. If we compare the current universe to an elderly person, then when the universe was only 470 million years old, it was akin to a toddler. Scientists used the Chandler the 10th Ray telescope to continuously observe the UHZ-1 galaxy for weeks, and discovered a massive nebula surrounding a gravitational source. Astonishingly, this gravitational source turned out to be a supermassive black hole, hidden at the core of the UHZ-1 galaxy. In 1915, Albert Einstein proposed the famous general theory of relativity, which profoundly influenced our understanding of the universe. However, even Einstein struggled with solving the mathematical equations precisely. Despite being a luminary in physics, Einstein remained humble in the field of mathematics. The equations were exceedingly complex and challenging to solve accurately. During the second year of the First World War, shortly after the publication of Einstein's general theory of relativity, a German military officer stationed on the Eastern Front, Karl Schwarzschild, came across the article. Schwarzschild, an astrophysicist and mathematical prodigy, found himself with some downtime amid the military activities and seized the opportunity to study the equations in his spare time. After several days of effort, Schwarzschild calculated a precise solution to the equations, later known as the Schwarzschild metric. He sent the results to Einstein, who casually opened the envelope but was immediately captivated by the contents. Upon careful reading and examination of the precise solution, Einstein couldn't help but praise Schwarzschild as a genius. On January 3, 1916, at the Royal Prussian Academy of Sciences in Berlin, Einstein submitted a paper on behalf of Schwarzschild, presenting Schwarzschild's computational results and expressing full confidence that the mathematical equations of general relativity would yield more precise solutions. His confidence stemmed from Schwarzschild. However, 4 months later, Schwarzschild's research career came to an abrupt end as he fell ill on the front lines and tragically passed away. Einstein was deeply saddened by the loss of such a genius, but had no choice but to take over Schwarzschild's work and continue forward. Fortunately, Schwarzschild's findings provided Einstein with significant inspiration, leading to the discovery of the most crucial solution for general relativity and the prediction of the existence of black holes, enabling significant advancements in the field. However, Einstein was astonished to find that the black holes predicted by Schwarzschild were peculiar celestial bodies that left people perplexed, as they harbored a region at their center called the gravitational singularity, where gravity was predicted to be so intense that space-time itself would break down catastrophically. Einstein was utterly baffled by this, as such a bizarre existence in the universe seemed highly unreasonable within his understanding of the physical world. Einstein's brain's CPU, already overtaxed from attempting to solve his proposed equations of relativity, was further strained by this peculiar Schwarzschild singularity associated with black holes. Unable to comprehend it fully, Einstein shelved the problem, leaving it for his colleagues to grapple with. This singularity baffled physicists of Einstein's era throughout their lives, eventually passing the enigma on to the next generation. In reality, the term black hole was coined by American physicist Wheeler in the 1960s. The most direct visual representation is depicted in Christopher Nolan's film Interstellar. In the movie, the massive black hole, referred to as Gargantua, is surrounded by a swirling halo, with an invisible boundary called the event horizon. Objects crossing this boundary are captured by the black hole's immense gravity, and even light cannot escape, rendering the region inside the event horizon a dark void. Of course, black and white are merely descriptions from human perception. Once light is entirely captured, what lies beyond is actually beyond the scope of our experiential world. Just as you can never describe a color you've never seen, it's impossible to accurately describe what a black hole actually looks like in human language. The term black hole is merely a convenient expression for understanding. The image of a black hole in the film Interstellar was crafted under the guidance of black hole expert and theoretical physicist Kip Thorne. The movie was released in the fall of 2014, at a time when astrophysicists had yet to capture the true appearance of black holes. Its appearance in the film was based on theoretical extrapolation, rigorous imagination, but still required actual observations for confirmation. 5 years later, in 2019, humanity finally captured the first image of a black hole. As mentioned earlier, since no light can escape a black hole's gravitational field, direct photography was impossible. Scientists achieved this feat by observing the movement and changes of celestial bodies around the black hole, indirectly capturing its image. This technique is akin to drawing a picture where the moon is not directly depicted, but inferred from the clouds surrounding it, leaving a blank space representing the moon. It's about evoking the imagination of the viewer. Therefore, capturing images of black holes requires employing similar methods. Despite scientific efforts, ultimately, it still relies on the imagination and comprehension of the observer. In 2019, scientists published the photograph of the supermassive black hole at the center of Messier 87, which has a mass approximately 5 billion times that of the Sun. In 2022, the supermassive black hole at the center of our galaxy, Sagittarius A*, also revealed its true appearance. In the photograph, the black hole appears massive, with a mass about 4.3 million times that of the Sun. It seems distant from our Earth. In the movie Interstellar, the protagonist spends several years on an interstellar spacecraft to reach the nearest black hole to Earth. However, contemporary physicists, after observing black holes, have come to a stunning conclusion. It's highly likely that our Earth exists within a black hole. Standing on Earth on a clear night, gazing at the sky, we see countless stars, most of which belong to the Milky Way, the galaxy where our Earth and solar system reside. It's challenging to associate these beautiful stars with the concept of black holes discussed earlier. As mentioned earlier, black holes are unique celestial bodies with extremely strong gravity, distorting the surrounding space-time, preventing even light from escaping their gravitational pull. If Earth were truly inside a black hole, how could it enter without being destroyed? Physicist Kanna from the University of Rhode Island suggests that if Earth were sucked into a black hole, as it approached the event horizon, time would slow down significantly, causing Earth to be stretched into a flat noodle-like shape. If the Earth were not destroyed during this process, then as it approaches the powerful gravitational center of the black hole, it still faces the inevitable fate of destruction. Therefore, the lively, vibrant Earth could not have been sucked into a black hole from the outside. It must have originated within the black hole itself. This idea sounds absurd, since the gravitational force at the center of a black hole, known as the singularity, is strong enough to destroy all matter. How could Earth possibly originate there and remain unharmed? In the movie Interstellar, the depiction of the black hole's center is as follows. The protagonist enters the black hole aboard a spacecraft, and after ejecting, he does not experience the destructive pull of the black hole's center, but rather enters a quiet, higher-dimensional space. The logic of the film suggests that an immensely intelligent civilization far beyond humanity intentionally created this space to save the protagonist, Cooper, allowing him to convey a message to aid humanity through gravitational communication, capable of traversing space and time. It appears that the film's technical advisor, Thorne, also acknowledges this possibility, that the interior of a black hole may not necessarily contain the immensely powerful singularity speculated earlier, but could harbor other space-time structures. Early calculations regarding the internal structure of black holes came from the father of the atomic bomb, Oppenheimer, who published his equations in 1939, predicting that black hole singularities possessed infinite density and gravity. However, Thorne and the younger generation of physicists believe that when a calculation yields infinity, it suggests a flaw, as the universe should not contain infinities. Everything in the physical world should have boundaries. Therefore, Thorne, representing the younger generation of physicists, brainstormed ways to discover flaws in Oppenheimer's equations or construct new theories to explain them. Of course, Thorne is now quite old, so when referring to the younger generation of physicists, it means they are younger than Oppenheimer. Some physicists, based on Einstein's equations of general relativity, calculated another possibility. As celestial bodies collapse to form black holes, when matter collapses to a certain extent, it may not form a singularity but instead undergo a bounce. Thus, it enters an expansion process. This expansion does not cross the previously mentioned event horizon, meaning it remains invisible from outside the black hole, but it creates a new cosmological structure inside the black hole. This cosmological structure within the black hole will undergo the following process. First, it gradually separates from the larger universe, much like squeezing a ball out of a piece of cloth, and then this ball detaches from the cloth and moves independently in hyperspace. This hyperspace is a highly curved space structure. Currently, all observation devices cannot see the internal structure of this space. This spherical celestial body's mini-universe floats in hyperspace, and there are several possible outcomes. First, it may merge with another universe. Second, it may also merge with the universe from which it separated. In both cases, the merged mini-universe will continue to expand, eventually delivering its substance into the larger universe, merging and becoming part of it. The third possible outcome, which we will focus on today, is the black hole's mini-universe, which continues to roam in hyperspace, unrelated to the matter in other universes existing independently. In the 1960s, British mathematician and physicist Penrose, through mathematical calculations, determined that gravitational singularities must exist. However, they are obscured by the event horizon, and we have no way of understanding what they actually look like. After Penrose's results were published, the mainstream physics community combined several previous theories and believed that the gravitational singularity inside a black hole must exist, but it may not necessarily destroy all matter. What this gravitational singularity is exactly? The mainstream belief is that it may be composed of quantum foam, devoid of any concept of space-time, representing a pre-universe state from which new universes may also arise. We know that black holes form from the collapse of stars, ultimately creating a singularity. As mentioned earlier, physicist Khanna believes that the universe actually originates from this singularity and will eventually collapse back into gravitational singularity, resulting in its destruction. So the birth and destruction process of the universe is just the reverse engineering of black hole formation, with both essentially being the same. Now here comes the interesting part. Khanna says, this theory implies that one universe can exist within another universe. So it's universes within universes, like a Matryoshka doll nested layer upon layer, and our Earth could potentially exist within one of these nested layers of a black hole. Since Earth is a planet within a black hole's mini-universe, what does the black hole we inhabit look like? Professor Field from the University of Massachusetts Dartmouth, specializing in gravitational modeling and simulation, says if this black hole is small, people would feel changes in time caused by its gravity or the stretching of matter. Even if these changes are minimal, we would still perceive them. However, the situation now is that we live on Earth and have not experienced any effects caused by the gravity of a black hole. Therefore, the black hole we inhabit is likely immensely massive, perhaps as vast as the observed universe. Professor Field's expertise lies in building models and simulations of black holes, and he says that if humans lived in a black hole's mini-universe, they would have no way of understanding the larger universe in which the black hole exists. However, what's intriguing is that our universe exists within a black hole. Remarkably, within this universe, we've discovered numerous black holes, suggesting a universe within black holes, and black holes within black holes may have given rise to mini-universes. It might be confusing, but essentially it's a concept of multiple universes, akin to saying that within a grain of sand lies countless bustling worlds, and within those worlds are grains of sand with each containing bustling universes. The story begins with the observation by the James Webb Space Telescope in 2023 of a galaxy formed during the infancy of the universe, labeled as UHZ-1. Within this infantile galaxy already exists a massive supermassive black hole, with a mass comparable to that of the galaxy itself, estimated to be tens of millions, even hundreds of millions of times the mass of the Sun. This dwarfs the massive black hole at the center of our Milky Way, Sagittarius A*, by several tens of times. According to current prevailing theories, black holes form from the collapse of massive stellar bodies after their death. So, during the infancy of the universe, when there were relatively few stars and it was relatively young, how could such a massively massive black hole have formed? This discovery has left scientists perplexed. They also found a huge nebula. Hovering near that black hole, swirling around, is material moving under the influence of its gravity. Kana and Field believe that this supermassive black hole is likely formed from the compression of multiple smaller black holes merging. Material drawn in by the black hole's gravity can form new celestial bodies outside the black hole, while inside the black hole, new stars and universes could potentially be generated. The two realms, inner and outer, are invisible to each other. But the flaw in this explanation lies in the fact that UHZ1 is just a galaxy from the infancy of the universe, and its internal stars at that time should have been very young, making it highly unlikely for them to have died and merged into a supermassive black hole so early on. So another possibility is that massive stellar bodies from older universes collapsed into black holes after their death. This black hole, after continuously accreting matter from the surrounding old universe and compressing it, formed into this massively massive black hole. And then, as described above, new universes were born inside the black hole, thereby forming countless different worlds both inside and out. Well, that's it for today's video. Thank you, everyone. If you like my video, please subscribe, like, and comment. Your support is vital to me.